Okay. Can you hear okay, streamers? All right, we're gonna get started. Do most of you have JD? Anyone running that stuff? Unlock download time. The JDK. I select out some stuff in our channel, some stuff that you need to install for today. Trent, could you help Kathy install the JDK? All right, so to verify it's installed, again, like I selected out, if you do Java-version in your command prompt terminal, whatever you're using, depending on your OS, you should get something that says like Java version 1.8. Along those lines, as long as it's 1.8 points, doesn't really matter what the minor version is. We just need over because we're going to be using some features that are only in Java 8 and above. So cool. So it's an interesting transition because we go over Java for a week, which is really interesting to me. It's kind of cool to look at another language a little bit more in depth. Some of you may decide you really like Java. I'm personally a .NET fan, so C#. I started my career in C#. It is far superior to Java in every way, but I'm also very biased. So I don't know too. How's everyone feeling about Fist 5 on React? Some people in there, some people. Yeah, it's tough. It's up there, so that's good. If you need more React after today, since I'm not your full-time instructor, I'm not going to make any decisions for the class. But after today, I'm comfortable with React. I would try to convince Robbie to maybe drop the Java if you don't want to do it and do more React. It's okay to do that. Trilogy itself made, advocating for that, but I think it's going to be more important in the long run with React coming out of this boot camp than Java. But it is fun to look at Java. We see something very different. So while people are for a real basic Java program, I'm kind of going to explain some of the basics of Java, typing, classes, the cool stuff that you'd see in a language like it. A lot of these apply as well to C#, so they're nice and transferable. They're slightly different. Both languages are very similar. So first things first, we're just going to cover the basic data types of Java. So right here I have this in my editor. I have two folders, collections and console. And inside the console folder, I have this console.io.java. First of all, there's one thing to note is that right? It's Pascal case. Every word is capitalized. And that is Java, the .NET languages, stuff like that. Generally, you'll see everything capitalized. You won't like we do with JavaScript. Now, functions are generally camel case in Java, but the classes and files are not. You also note that there's this package at the top of the console.io.java file. Same name as the console folder. Works for better for worse is your folder structure is directly related to your package names, and you have to have this package name. So if I had a folder structure that was com, and then the next folder was console, my package would be com.bootcamp.console. It's just the way Java. It is what it is. It's kind of weird, but it's Java for you. The next thing you'll see is we have this import statement too, and it is kind of familiar. So JavaScript, and this is vaguely, not totally similar, but this is effectively how you do it in Java. And tell it it's important and how you want to use it. We're not assigning it to anything. It's just kind of vague. Does properly. We won't worry about the explicit moment, but you'll potentially a little bit today. So there's a couple of things sort of familiar about Java. But at the same point, they work very differently. And Java. Does everyone remember classes? We had class keyword a little bit. Classes are loosely based off of classes in Java. So object-oriented languages, they come from languages like C++. Classes and classes for your functions. They're more than that, but that's really what they are. And they are a type. So we have a language that has types in it per se, but you don't see it in the same way that you'd see it in Java. So for instance, we might have a string, we might have a number, we might have a Boolean or an object in JavaScript. We say we have those things. Like we never say, hey, we have number x equals 10, right? We just say constant x equals 10, and JavaScript kind of figures it out. And that is because JavaScript is a dynamically typed language. It's a statically typed language, which means you have to define all of the types that you're using. There's pros and cons to this. And there's a huge debate in the community of which one. My personal opinion is for small prototype, dynamically typed to make a lot of sense because you can go really fast. You don't got to worry about a lot of the details. But for a large, safer, and a program that requires maybe a little bit more stability and needs to be tested a little bit more thoroughly, statically typed languages are better because they're a bit more explicit. And what I found in my career is being explicit is good. In a language like JavaScript, and pretty much anything can happen, the less likely another developer is to come in and misinterpret what you were trying to do here. And it's very easy at some point with all this code to misinterpret one little entire what was happening. So statically a little bit more to prevent those problems because they have static type filed so of static analysis while you're compiling to tell you if there's a problem. So, for instance, you have a string, and then you have a function with a definition that's expecting an integer, and you pass in the string. Well, Java's compiler up front, before you do anything, is going to say you can't even do that. So what are you doing? And stuff exist in typed languages like this because they just literally cannot. Speaking of compiled languages, Java is different from JavaScript in the sense that it is a compiled language, and JavaScript is generally an interpreted language. It's interpreted, and you don't do anything to your JavaScript files in, like, say, Node to run them. You just tell Node to run them, and Node grabs the files literally as you see them on your machine, and it just interprets them, turns them into something else. It's machine code. Java actually has a compilation process. So to use Java, it Java files and creates a .class file, and a .class file is what's called bytecode, or the Java virtual machine. What it does is it takes this bytecode that you compile in Java, and it actually turns it into machine code at runtime. You decide you're going to run them in a good old Java program. It scoops them all up, and then as Java literally turns it into machine code. The best ways to out and do all Java because it's one of the things very interesting. A lot of other languages do now. It's fully managed for you, right? It's cross-platform in the sense that we make this bytecode for Java that doesn't have anything to do with the machine you're on, and then the JVM itself, all that stuff that you guys just downloaded, can then fit for the specific machine you're on. It's a bit of a detailed talk to go into, but just note that you can't just run Java code. It doesn't compile it, and there's a lot that happens. And during that compilation process, so anyway, Java, they represent only a container represent type. If I were to try to use class, like say a function, I would have to say class, or when I would create a new instance of it or something along those lines. Another thing that's different about Java is it has these modifiers. Like in Node and in JavaScript, effectively everything is public. We don't have any way to hide things that are part of a class or hide things that are in a file unless we do, right? But you can actually say, I want certain private, and there's not anything else to have access to them except for this console.io class. So you can imagine I import the console.io class. It's got a private function on it. I call it function because the access modifier is preventing me from doing so. So while we're just learning the basics of Java, it's important to try to keep everything public, explicitly public, so that I use it until we start to understand a little bit more about these access modifiers, private, protected, stuff like that. Because there's a few of them, and they mean different to Java. So all the structure doesn't look too different from JavaScript, right? We have the curly braces. JavaScript, the same structure as this modifier in Java. Now, another keyword we have that does kind of exist in JavaScript, but is fairly new, is the static keyword. And we have public, static, void, and main. That is a mouthful. With these little braces, args. Does anyone know, who can read as much of this as possible? Anyone wants to give it a shot? What this function is saying. Kind of intimidating. So public, accessible from anywhere. Static is a new keyword that we've not dealt with. And static basically means there's, the easiest way to put it is there's only one. So you can imagine I have a class like console.io, something like console.io equals new console.io, right? C isn't going to have the class main on it. It's just not going to exist. Console.io.main. And the difference is things as a whole, and things are not static related to an instance. So anything marked static, you're going to access directly from the class. And not access from an instance, kind of like we would do in JavaScript, where if we had another function, say it was print, you would call it like so, right? And that would be a non-static method. So static's a new one that you don't really got to understand it too much now, but it exists in a lot of these object-oriented languages like C# and this in C and C++. JavaScript now with ES6 and it works the same way, where static means there's only one. Now, languages in C#, they have this function called main. And the main function is the entry. So there's one entry point to every application in these compiled languages. And every single one, you can go down to assembly, there's always one single entry point, and it's usually called main in assembly, but in C, C++, Java, C#, Python even, it's called main, all right? It's just the entry point. Void is the return type. So we actually have a slight difference here too. If you've ever seen, has anyone played with things like TypeScript yet? Typed JavaScript? Yeah, a few of you, that's good. So if you have, most of you haven't, and that's okay. The return types actually come after the function declaration. So you'd see something like void. Void effectively means nothing. So what this function is saying is it returns nothing. There's no return value. And in Java, it's a little different than JavaScript because that holds true. You can't, in Java, you can kind of fudge things a little bit. If you don't have an explicit return, you're actually returning undefined, which is really kind of weird. So say you were in JavaScript, you could do like const x equals c.main, say, and say main return nothing, you would actually get undefined. But in Java, you can't do that. If there's no return value, you can't set it to a variable. Java will explode and be like, that's stupid. You can't do that. It doesn't return anything. And that's part of this typing and this compile time checking that you get that's nice about languages like Java. You literally can't assign this to a value. It doesn't have one. There's literally none. The last thing to look at here is we have this string with capital S and these two brackets. What this means? Very similar to JavaScript, these brackets. An array, maybe? This is an array. Basically says an array of strings. What would an array of strings look like? Would it be a string, or would it be literally an array with different strings and different elements, right? So what the main function accepts is an array of strings, which are the command line arguments to your program, right? So you would run this program, and maybe you could pass in name, and then like your name, and age, and then like your age. These are the command line arguments. They come in literally the order that they're parsed from the command line. So, you know, the first one is index 0. Index 0 might actually be the program name in Java. But anyway, the first one is index 0. The second one's index 1. Basically, that's all it is. You want to get to the command line arguments, they come through main like this. And then you can do whatever you want in your program state. But the important thing to note is the type. Type that we do not have in JavaScript. Strings are exactly as they are in JavaScript. They're strings, okay? There's certain things you can do. You can add two strings together and make one big string. You can do substring. They're made of characters. Character is another individual type in Java that is not in JavaScript. JavaScript has this concept of just a substring of a string is another string, but you can actually rip a single character out of a string in Java and make it a different type, which is a char. And the char is effectively just that single character, because single characters in machine code can be expressed as numbers, right? So they're different than strings. So strings are very similar to what we're used to now. They do have some slightly different properties in a typed language and a compiled language like Java. But as far as you're concerned, string is a string. Just now have to declare it with a string, capital S, for the variable name. The other thing, too, is in JavaScript, we have the fun ability to be able to denote strings in single quotes or double quotes. In Java, strings have to be in double quotes. If you do something in a single quote, it is a character, and it will not work of anything greater than length of 1. So if I were to try to do this, I'm in VS Code, so it's not really giving me like syntax highlighting or anything. If I were trying to compile this, it would say you can't do that because it is not a string, it's a character. To make it work with single quotes, I would have to do something like that, right? And then I'd have to probably assign this as a char. Basically, that's the difference. So double quotes it is for all of our strings from here on out in Java land. So we have this fun type in JavaScript called number, which effectively represents any number that you could pretty much think of. It has a limit, but it's a crazy limit. It pretty much does whatever you want. In dynamic languages, that's generally the case. We generally just have like a number that does a bunch of stuff. But in typed languages like Java and C# and C, we no longer have the concept of just a number. We have things called integers. And there's actually a specific type called integer, abbreviated as int, and it represents a 32-bit integer. Does anyone know what that is? 32-bit integer is made up of 4 bytes. There's 8 bits to a byte. And what that means is you have a very large range when considering the types of numbers that it can accept. An int can go between -2 to the 31st power up to 2 to the 32nd power, which basically means it's like -2 billion, 100 million something to 2 billion, 100 million something plus 1. Is basically the range you get for a regular int. Now, as I said, we don't get the ability to just put any number willy-nilly in there. We have a range. So how would you want a smaller one? Say you only needed a 16-bit integer. There's something called a short, which doesn't accept as big of an integer. And the reason why you might do this is for memory usage, right? 2 bytes is half of 4 bytes, so you save 2 bytes. But say you wanted something bigger than that 2 billion or 21 billion or whatever that number is. Say you wanted a bigger number, you could use long. Long is an even bigger one. It goes up to the trillions. And then say that's not enough, you can use something called double. There's a distinction though. Int, long, short, bit, byte, those kinds of types, they cannot accept decimals. They are whole number integers only. No fractions, none of that fun stuff. And if you tried to use a fraction or a decimal there, it would round it. It just has some rounding algorithm you use. It just pretty much truncates the decimal part off. It's like, you don't need this. If you want to use a decimal, you have to use a type called a double. A double has a really crazy high range because it accepts that decimal. You could do 1 to like 30 decimal places, or you could do 29 numbers to 1 decimal place, or something crazy like that. I forget exactly. There's some math behind it. But they have double to effectively represent your decimal points. There are other types too that work with this. There's one called float. It's like a smaller double. Float is to int what long is to double, right? So double is much bigger than float. They're both floating point numbers is where they come from. And then there's another one called decimal, which is a high accuracy version of a double. So if you wanted to represent, say, currency, you would use a decimal type because it's more accurate. Double is used for fast calculations. So assuming you don't want accuracy up to a certain number of significant digits, which you don't really care about in most calculations, you could use a double. But say you're doing money math, it's really important up to a very significant digit that you're accurate, or else people start losing a lot of money. And you may say, hey, you only need 2 digits, right? 2 decimal places because that's money. That's not the case in computers. You need all of them. You need as many as you can get, probably up to 19 or 20 if you want to be very accurate, or people are going to lose money and you will be sued. So don't do that. And that's a caveat of that. But anyway, the important thing to know about double is it is effectively your numbers that have decimals, okay? It's your fractions, your non-whole numbers. That's what you use double for. We also have our Boolean. We all remember Booleans, true, false, or whatever. We have a very similar Boolean here in Java. We even have the bang here, the exclamation point, to denote not. So true, not true is going to be false. There's something you get in JavaScript, though, that you don't get in Java, and that is truthiness. So truthiness is the idea that we could take, say, the number 1 and do if number, then something else, right? Because the number 1 always evaluates to what? True. In JavaScript, the number 1 evaluates to true. What does 0 evaluate to? What does negative 100 evaluate to? Anyone? True. Any number other than 0 evaluates to true, 0 evaluates to false. And that's called the falsiness property in JavaScript. 0 is considered false. Okay, great. It's false. I don't know why. It just is, right? Technically, it is. If you were to look at the bytes of your machine and you were to look at machine code, that's the case. 0 is false. And anything else is true, effectively. But in Java, you don't get that fun. You can't just say, like, hey, this empty string is false, so I'm going to do something. You literally have to check true or false. You can still, with a Boolean type, do your conditionals where it's like, if truth, then something, right? So you could do if truth, then do something. But if you had another type, like say we had name, you would have to do, you have to do the full thing. Cleopatra, right? You couldn't get a truthiness check. Say you wanted to verify that there was something here in this string. In JavaScript, you could do if name, right? And if it was anything other than an empty string or null or undefined, you could go ahead and continue in its conditional. But in this one, you have to do like a dot length on it. And you have to see if the length is greater than 0. So if dot length greater than 0, then it's true, right? There's something in the string. You don't get that implicit truthiness with stuff in Java because those types are not Booleans. Those types are strict types. They're strings, they're numbers, they're doubles, they're objects, they're arrays, they're something other than a Boolean. And you can't just magically convert everything to a Boolean in Java like you can in JavaScript. So that's another distinction. Any questions on these types that we've covered so far? I know this is a lot, and this is very different than what we've been doing so far. Cool. We're going to continue on. Okay, so we're going to look a little bit of functions here in Java and how they work. So they work very similar to how we use them in JavaScript, where basically there's some parentheses and you call the function and pass in the appropriate parameters and magic happens, right? So we have this system.out.println, and as you could probably imagine, println prints whatever line you put in there. So this is like our console.log for Java. It's effectively this. It works a little differently because it's in Java and ties in more to the actual inputs and outputs of your machine as opposed to the V8 engine that JavaScript uses, but that's okay. And then we also have this cool thing called string format in here. Why they did this is the first example is beyond me, but they have it. So let's go ahead and look at this print really quick. You can see if we just wanted to print a very basic string, you would just pass in a string. And notice this one is print, not print ln. Does anyone have an idea what that would signify? Well, how that would be different? Oh, well, I guess it says in the text there. Never mind. That's an easy one. There's no new line at the end of this print. As opposed to the print ln, print a line, there is a new line. What's a new line? That's like your /n, /r/n, stuff like that, right? That represents a new line in your terminal. So if you go ahead and you print a new line, if you just were to print \n in a console log, right, you'd end up getting two lines because console log always appends a new line to the end of its log. It'd just be an empty line. So print line, if you want the lines you print to be separated by a new line, you would use it. If you just want everything to be in one long row, you'd use print. So there's this other thing, the string format. So I don't know if console log has it in default in JavaScript, but there's these string formatters you can use in very many languages, like you'll see here, %s and %d. They represent the type of whatever that you're trying to print into the string. So you can't just take a number and put it in a string in Java and have it magically print to something. It doesn't work that way. It'd be nice, but it doesn't. Instead, you have to do a very explicit conversion from a number to a string. And an easy, hacky way to do that is to use this string.format function, right? So string is the type. So we have that type string that we've seen a couple times now. Literally, the types have built-in functions, and this would be a static function on the string type. So why wouldn't this be an instance function? Well, because string format just returns a new string. We don't need to do like .length or .substring or anything that would actually affect the string we're talking about. But anyway, we have a string format function you can use. You tell it %s. This is going to be another string that we're injecting into this string. So wherever it says %s, you'd have a parameter passed in after the string that represents another string, and it's going to inject that one into this %s. So in this case, name is going to be injected in place of this .s. So it's a Cleopatra is. %d stands for generally number or decimal. I don't know if Java has a difference between the two in string format, but in some languages they do. %d is usually just like an integer, right? And in this case, we have age, which is an int, int. And so what this is going to say is Cleopatra is, what is that, 285 or 2085 or something, years old, right? See the replacement there? %d was the age, %s was the name. Now, you may be wondering, how do we know how many parameters to pass in? However many of these replacements, these string replacements you have, is how many parameters are going to pass in. This function takes as many parameters as it needs to get the job done. And what it does is creates a new string that we're then going to print out to the print line. So again, it's just normal function like we see in JavaScript. And this is a cool thing we can do in Java to do our string conversions for us, since we don't get those for free anymore. So Java also has ways that you can go ahead and get input from the user. So say you have a program, you run it, that's all well and good, and you want to get like a name from them or whatever. What is your name? They have to enter in the console, hit enter, and then you can get that and then use it in your program. JavaScript has this too. Node has this, but we haven't. I don't think we've done it that much. You might have done it in a lesson. But we have another way to do it in Java too. It's a little bit more intuitive. So we have this import Java util scanner. This is saying we want the scanner class imported directly in so we can use it. And here it is. Scanner input equals new scanner. So this is another class like our console.io, and we're instantiating it. Okay. So we're creating a new version of that class so we can use it as a variable in our program. And then it's got the system.in. Does anyone know the difference between standard input, standard output, standard error? Or know what they are even? Can anyone tell me what those are? Your computer, every computer running a has 3 effectively streams. I don't know how to put it. You can imagine that they're files in a Unix system. So on a Mac, okay. So standard input is file 0. It's literally marked 0 on your machine, and that is the input. That is your keyboard. That is everything that can give input to your machine. Standard output is file 1 on your machine, and that is everything that is written out of a program to your machine. So you can imagine every time you have something written to the console in Java or JavaScript and Node or whatever, it uses that standard output, that file 1, to write it somewhere. And then standard error, which we're not going to use here, is file 2 on your Unix-based machine. And that is just any error output, you'll put it there. Does it do anything different? No, but we just know that file 2 is where we have all of the error that's been happening in this program. So this is saying we're hooking into standard input, file 0, on my Linux machine here, and we're going to be taking any input that the machine gets at a certain point in this program's execution, and we're going to accept it into our program so we can parse it out. So println, what println does is it actually writes text to standard out, which is file 1, right? It'll actually write to that standard out. Standard out will then send information out through this text to the command line, and the command line will be like, oh, I'm going to print that. Great. So basically, we're going to enter a sentence for me to read. Then what's going to happen is this scanner that we instantiated here, input, is going to read the next line. The next line is literally the next line of text from the standard input that ends with a new line character. So that's /r/ talking about, right? As soon as it finds that first new line, boom, that's what it's going to pull in as a string called sentence. And we can print it out. We can literally do a system.out.print line, and or even .print because it ends with a new line, and print out sentence. And we get it back on standard output, which would just be the same thing that we just entered, right? So now we're going to try to print a single word, right? So we print out the standard output, enter a word for me to read. And input.next is going to literally read the next word. How does it denote a word? It looks for a space. As soon as it finds a space, it's done parsing. It says, I don't need anything after the space. Bring me one word. So if I were to be prompted to enter a word for me to read, and I typed Carson space Howard and then hit enter, it would only pick up Carson because that is the only word. So next isn't going to look for those new lines. It's going to find the language appropriate, which is almost always space, denotation of a word separator, right? The word delimiter, which is the space. Enter an integer for me to read. So one thing that's interesting about types coming from the command line is they're always strings, right? You can't enter a literal number into your machine and tell your machine that that is a number if it's on the command line, if it's on the terminal. If you're in a text editor like Notepad or Word and you're typing text, it's a string, right? It literally is a string. Even if you type 1, it doesn't magically change into a number. So we need to tell standard input that whatever we get from the command line, we need to convert it to a number. So it's going to be a string, convert it to a number, and assign it to this integer variable. What it's going to do is the same thing that next does. Look for the first space, bring it in, try to parse it as a number. If you don't give it a number, it'll explode. It'll just give you some crazy error and end. It'll be like, that's not a number. You told me it'd be a number. So there are ways you can be a little safer about it, but effectively this is looking for just a number and hoping that your user gives you that. Same thing down here. Enter a double for me to read. Double dub. Inputting thing is into a double. So this could be any number, really, as long as it conforms to double, which is effectively anything in the number world. You can have decimals and all that fun stuff. But again, if it finds something that's not a number, true, Carson, something like that, it'll just explode. Because we have type safety here in Java, it cannot accept something that's not the type it's expecting. It just cannot do it. That is not how it works. Whereas in JavaScript, we may say, I expect this to be a number. We get a string, and we are on our merry way, and we deal with it. And then we find out a whole long time later that it wasn't actually a number, and we were just guessing. Java is not that friendly. So I'm going to quickly just make sure that I don't have anything in here that could potentially break it. Doesn't look like it. I'm going to close it so I don't save any changes. I'm just going to show you what happens when we compile this. So Open up here. We have our Java, right? So you can check the Java version. I'm using a different version. I'm using Java 10. I installed that today. That won't really matter for this. But there's another process called Java C. Use CP, which effectively is class path. So you're looking for classes. So remember how I said, because our package is console, Java is expecting us to be in a console folder. I basically have to tell it to look in the console folder. And I'm already, I'm actually not in the console folder. So if I go to the same, folder as my console.io Java class, I have to tell it to go up one directory to look in the console folder. Then I tell it the name of my class. I spelled that wrong. I typed something wrong. Last. That's okay. That is okay. Oh, it's not Java C. My bad. It's just Java. So you tell Java to compile this. I broke something. Console. Did I spell console.io wrong? Well, I'm doing something wrong. Console.io. Might be because I have this collections folder in here. Bummer, that's stupid. See if I can get this to file. Okay, well, I can't get that to compile, so that really sucks. But we'll go over another example really quick right after this. So basically what would happen is if this was working, oh, I'm stupid, I skipped a step. I do need Java C, but I need to tell it to compile the .java files into class files. Okay, so remember earlier how I said I need the .class files because it turns the .java files into machine code, or bytecode, I'm sorry. And that bytecode is then what is run by the Java ecosystem. And that's what was happening is that I actually forgot to compile it. So that was that first command I was trying to run Java cp ... whatever. That was the effective equivalent of node console.io.js or whatever, right? So I was basically trying to tell it to just run it, but I didn't have anything to run. So if I do Java cp console.console.io, it'll run it. So now we're running a Java program, legit Java program run from that console.io.class. So Cleopatra is 285 years old. All right. That's right here. Cleopatra, name is 285 years old, age. And this string won't have a new line appended. And you can see right here, there's no new line between that and the next print, which is enter sentence for me to read, which ends in an ln, so it gives me a new line. I can type something in here, tense, which I spelled wrong because I don't know how to spell. And it just continues on because we don't print anything out from that string sentence. Enter a word for me to read. So let's see how this word parsing works. Did not like that at all, did it? Gave me an exception. So it didn't even like that I gave it multiple words. And here's the reason why. So you know how I said it goes in and parses based off of a space? What's happening is it's looking for the next word that I entered, which is Carson. Then there's another word left on the input buffer. So it's like, oh, go ahead and give me an integer to read. Oh, Howard's there. It pulls out Howard. Howard is not a number, is it? So it says exception in the main thread, input mismatch exception. You get this crazy thing printed out. Basically, it's looking for an int. You can see it even says java.util.scanner.nextInt. It's looking for an int, but it grabs Howard and just fails miserably. So if I run that again, enter some garbage. I enter Carson, we're all good. I enter 10, we're all good. I enter a crazy weird number, and we're all good. Everyone kind of see how that works? I know we're still very vague on the whole Java thing, but it's very, very different than what we've done. This is just a very basic example of it to kind of get your feet wet. So we were actually supposed to spend 10 minutes on that, but we spent like over a half an hour, almost 40 minutes, because frankly, there's a lot going on in here, and I really don't think glossing over the details is going to be very helpful for anyone. So what we're going to do is we're going to do an exercise. Hopefully everyone's got this installed. If the TAs could Slack out O2 console unsolved, console IO unsolved, I'm going to Slack out an example file to help you all that you can use as reference. And you're going to basically be doing an activity like this where you're going to be console logging stuff related to your portfolio that you've been working on all class. So we're going to spend a few minutes working on it. And then we'll go ahead and go over it. So I slacked out a console.java. You can use that as your reference. It's a big file, so if you want to download it, by all means, do.
Yeah, Matt.
Yeah, you'll have to edit your path, but you would figure it would come automatically with the installation.
For other people not getting
For Java C, yeah, on Windows.
so it's probably the path to that executable.
So here's a link. It should help you for Windows users, Windows 10 users. 8 can follow the same path. But basically, when you install a program, something called the path on Windows needs to be updated if you want to use it from the command line. And you would think the Java executables would install Java C on the path, but they don't. So you have to do that yourself. And I don't have a Windows machine, so I can't demonstrate it. But basically, you go to these environment variables, you edit them, you find the one called path, and then you add the direct path to that Java C program, or at least to its parent folder. And then you can restart your terminal. It's important that you restart your terminal, and you'll be able to use Java C. The other thing to note is when you go into C program files, Java, you'll see JDK 1.8 point whatever. It's going to be whatever one you got, 1.8 point whatever. It doesn't have to match the one in the example in this answer on Stack Overflow. Just know you got to go to JDK, your version, 1.8.xxx/bin. That needs to be added to your path. If anyone needs help, you can let me know. I'll come help you.
So you have the Windows environment variable.
So basically, we're going to be building. Hey, Trent, did you Slack out the activity?
No, but they should have it.
Can we?
They were told.
So there's an activity. Is there any questions to the results? Yeah.
Java C, and it should give you a list of commands.
Hit pull dash dash. Well, yeah, so what happens
Java
is
C.
you get unstaged files, unstaged, non-existent files, files. It doesn't matter if you get they don't exist yet, right? So their files didn't fold for some reason they didn't get. I've had this problem with they don't get like added properly. That happens.
Yeah.
So basically, it's like I don't know. It doesn't matter what you said or check out. You're just like adding the file. Save this install. Get index. Dash dash have that. Just fast forward. And what that means is we're right here. Max here, right?
And then environment variables. Edit environment. And then click on variable value and go to browse directly. This piece, yeah, whatever choice.
Is exercise 2, Preston?
Yeah. Unsolved 02.
And then all kernels reopen and do Java C it should be
All right, I just posted the compile and the run commands in Slack. I didn't really go over them very well. But we have to move on because we're running out of time, and I know probably no one got anything done on this one. That's okay. I don't expect you to get a whole lot done today. But to explain the Java and the Java-C commands really quickly, in more depth. So we're in this console folder, right? And if I open it up in Visual Studio, you'll see in console I have the console.io.java, right? And so I'm saying Java-C star.java. The star means find everything that ends in .java. Java-C means compile the Java, right? So we're saying compile all of our Java classes. That's what the Java-C is for. If we don't compile it and get those .class files, we won't have any bytecode to run with Java. The next is Java-CP class path. So this is the path to the class we want to run. .. because our package is console, so we need to go up one to the so we can access the console folder, and then console.console.io. The class is console.io.class. The package is console, so it's console dot the class name. It automatically appends the .class. You don't need to do that. It does what it needs to do to find it. But basically, that's the identifier for that class file we have created, and then it runs it. Today, and I know we didn't really get to go finish this exercise. We had to move really fast, and I'm sorry about that. But we're going to get a lot more exercises in, so we'll be able to get something done. But we are going to cover it. So this one was effectively another take on what we did in our example. Again, I don't expect anyone to have made it very far at all, if even done anything. But the first thing we need to do is we need to find a way to read the system input. So in the directions, basically we're going to have this program that allows you to enter a bunch of stuff, and we're going to parse it, right? So like in our example we went over, we have the package definition of console. We are importing the scanner, and we have our class console.io. Standard stuff. This is all written in the main function. I don't expect you to understand why it's standard, but it is, and we're just going to keep that the same from our example. The first thing we need is we need a new version of this input class so we can read system, the standard in, system.in, right? Standard input. Then we want the student's first name. You enter your first name. Remember, if you put a space and you did like your last name too, you might cause problems. You wouldn't in this case because it's looking for the last name, so you just skip a step. But it could if this was looking for something else. So you enter your first name. It's going to get your first name there. Enter your last name. It's going to store your last name there as a string. You put your middle initial. It's going to go ahead and try to get the middle initial, and then it's going to just skip a line. It's going to say, boom, we're just going to go ahead and skip a line. We don't need anything here. No problem. It's basically just like a truncation at this point. Then we want to get the address. We're going to take a full line for the address because the address is long. It's not delimited by spaces, right? 123 West Oak Street. There's a bunch of spaces in that, but we need all of them, so we need to get the next line. And your email address. There's no spaces in an email address. The phone number. No spaces in a phone number. Well, there could be, I guess, depending on how you write it, but in this case, there's not. There's either dashes or there's nothing. It's just 10 digits. We'll get the phone number out. This right here would be a good example of where you can make it more robust by looking for a legitimate phone number written in many ways. Maybe you have parentheses around the area code and spaces to delimit. It's a valid phone number, right? But this is a really naive implementation of grabbing the phone number. Then we're going to go ahead and print everything using string format. Boom, a bunch is printed. And then we say, is this information correct? And we just get the confirmation. And then from here, we could say, if it's Y, go ahead and say, yeah, it's great. If it's anything else, and say, okay, we'll do this again, or something along those lines. So that is the gist of what this assignment was. I'm pretty sure. Let me just verify that there wasn't anything I missed there. Yep, that's it. Cool. So, any questions on this activity? I know we're moving like really fast on this one, and there was still probably a lot of things up in the air that you people don't really understand yet, and I expect that should be expected at this point. Does anyone have anything outstanding questions about any of this process? Anything we've seen so far that they'd like answered before we move on? There's really a lot going on, so cool. Well, then we're going to go ahead and take a look at the next thing, and that is going to be more advanced types. So we actually have a lot more we can do in Java that we've been able to do most of this stuff in JavaScript, but we can now use types to do it. So first things first, there's arrays. We're all familiar with arrays in JavaScript. They just have the little brackets to denote that they're an array, and they hold basically any number of elements. And arrays in JavaScript are magical because you can just push stuff to them or pop stuff from them and spread them and do all kinds of crazy things, and you can pretty much manipulate them at will. Traditional compiled languages are not so fun in the sense that you can manipulate things just at will. You can't. Arrays are very, very static in Java and similar languages in the sense that once you define an array, that is what the array is. It can only have a single type. It can only have a defined size. Can't change it. Array is just literally what you tell it is. Nothing about it changes. So the initial variable declaration doesn't look too foreign, right? Because we're basically saying this is an array. And the way to do that is you have the type and then the brackets here, the braces, right? To say that it's an array. We could do this with an int as well. So we could do int. We call this nums. That's an integer array, right? But you need the type, you need the braces, you need the variable name. This is an uninitialized array. There's literally nothing here. It's not undefined. It's not null. It's just nothing. This is not a thing. It is literally in your code right now. If you were to compile this and never initialize it, it would just not exist. Java would just take it out because it doesn't exist. It's really just a variable declaration. And right here, we actually initialize the array. Already can tell this is a little different. So in JavaScript, we may have something like names. Oops, names. I can't type today. Equals like that, an empty array, right? And the array is just, it's actually a list. It's just like whatever you want to put in it is great. Put numbers, strings. In this one, again, we have a concrete type, so only strings can go in this array. And right here, we have the size. There are only 3 elements in this array, and that's it. You can only have a max of 3. Nothing more and nothing less. It's just always 3, right? That's the length of the array. And that is a requirement of arrays in Java. You need to give it a size. You may be asking yourself, if I have to give it a size, what happens if I have more elements and I need a bigger array, or my requirements change suddenly and I need to change the size of the array? Too bad. Got to make a new array. Now, there's other things that work around that in Java. We'll get to those. But for now, just note that an array is very, very static in its size. As you can see in the comments, the array's length is set for life. Absolutely the case. So there's another way you can initialize an array, and that is by directly injecting the values into said array. So right here, this is the equivalent of saying that you want 3 elements injected into this array, but you're giving it the values up front. So we're saying we want 3 values in this array: Julius, Cassius, and Pompeius, right? And that's it. This array has a length of 3, and that can never change. Or you can initialize the array like we did names with an empty array of 3, and then you can give the values to the individual indices. So this is similar to JavaScript, right? We have the 0, the 1, the 2. It's 0-based indices for our arrays, just like JavaScript. These are our 3. Now, what are the values? Anyone have an idea of what the value of name 0 is before we set it to Julius? Because it exists. It's equal to something. Anyone have a guess? Weird garbage, undefined. Those are good guesses. Undefined does not exist in Java, though. Undefined is an interesting and terrible construct of JavaScript. It is null. Strings can be null. Not really. You can put null in the place of a string because string is a reference type, which we can discuss later. But basically, certain values in Java and other languages have the ability to be just null or that's effectively your undefined, right? Undefined and null in JavaScript are technically different, but you can think of them as the same in the sense that they're like no value, the absence of a value. So when they're defined initially, they're null, which null is technically a junk value. If you're to look at it in the sense of like C or another language, it's just handled a little differently in Java. So it'd be null until we set it to a string. Now they're strings, and we're all good. So arrays, we're familiar that we can iterate over arrays. We can in Java as well, with a very similar syntax to that of JavaScript. You have a dot length, and you can just go ahead and have an integer I. Again, you got to give it the type, and in this case, an int is a perfectly acceptable type for your I. And it's 0, I is less than the length, I plus equals 1. And then you can go ahead and print what's in that index of the array. So this is very similar to what we're used to. Not much has changed there. That's the case in most languages. Go ahead and print a separator. So if we run this, we can see. And there's also this cool for syntax. So has anyone seen for of or for in JavaScript? Anyone played with that syntax? We might have played with it a little bit in the ES6 stuff. But basically, this is the same. This is saying for every element of triumvirs, I don't know, pronounced that wrong. For every element of triumvirs that is a string, we're going to call it name and then print that name. So this will just automatically go through the array and just terminate when there's no more elements left in the array. So it's kind of a nice syntactical sugar there. So you don't have to, create a variable I and make sure that it doesn't go past the indices. So it doesn't like try to do names of 3 or whatever and then explode because that's not actually an indice there. So just a nice way to do array looping. And you'll see this a lot. And this is actually a construct we'll see with other things other than arrays. Any questions on arrays in Java? Ooh, we're going to move on to a more advanced version of arrays that are more familiar than Java arrays, and then our array lists. So what we know in JavaScript as an array is actually a list. And a list is a data structure that is basically a resizable array. It's not actually, because arrays cannot be resized, but the implementation of array list behind the scenes basically takes in whatever garbage you want into the array, and then when it hits the maximum size of the array under the hood, it's going to go ahead and create a bigger array for you, copy the elements of the old array to the new one, and you're all hunky-dory without ever knowing a thing. That's what the array list does. It's a very nice way to do it. It kind of takes the pain of an array away because, frankly, what are you going to want in an array in a language like Java? How often do you know exactly how many elements you have? It's pretty rare. And that's the only time you want to use an array, is when you know exactly how many elements you're going to have. Other than that, you use something like an array list. Now, array list has some pretty funky syntax on it, though. You can see it's kind of weird. It's got these angle brackets. Does anyone have a guess as to why it's got these angle brackets and what they could potentially mean? Is it the type? Yeah, absolutely. Array list is what's called generic. Java it has these cool things called generics that you'll find in other languages like C# as well, and even in C++ called templates. And basically the idea is we want to create this array list type, right? So this special self-resizing array that we can use like a list in other languages. And we don't want to limit it to just being strings. It would really suck if for every type we made, so every class, every number, whatever, we had to make a new array list class and re-implement everything again and do it for that type. When we know everything about the array list is going to be the same, the only core difference is the type we're handling is slightly different, right? And in the sense that the type is different, basically what you put in, what you get out are different. But anything else related to the array list is exactly the same. How it actually functions is exactly the same. So Java has these angle brackets to specify a generic type. So basically this array list is bound by the Java compiler to only handle strings from here on out. If we were to put int there, which we could, all of this code right here would fail. You can actually see I'm getting an error. Dimensions to complete reference type. Okay, that is the wrong error. My Visual Studio Code error handling is not working. But anyway, strings are okay, and these abs will be fine because we're expecting string. Now, you can see on the other end here, it just has like a diamond-looking thing, which is just your empty angle brackets. It's effectively to fill that in for you without having you to do any of the work. It's just shorthand syntax, and it's kind of nice. But angle brackets are important because they're generic, and it lets you use the same data structure over and over for different things. We can go ahead and add strings in here as opposed to directly referencing the indices. We're going to do .add, and it's going to go ahead and handle the array garbage underneath the hood for us, so we don't got to think about it anymore. And then if you want to get a specific indice out, you still can. Use this function .get. .get the indice at 0. It's going to go ahead and do the math for you and pull it out of the array at indice 0. Remove 0. Now here's the fun thing. You can remove stuff from the list. You can't really remove stuff from an array, right? You could take indice 0 and replace it with something if you wanted, but the idea of removing something from the array doesn't necessarily exist because the array cannot change in size, right? So if we remove 0, what it's doing under the hood is taking that first element of the array and let's just imagine it's gone now. And when we go ahead and we print 0 again, we're actually going to get Cassius instead of Julius Caesar here, because the array list knows it should no longer have that first element in it. To replace the value at an index, we can use the set function. Set index of 0 to Julius Caesar in a weird kind of spelling. It's supposed to be hip or something. I don't know. And what this is going to do is take what's currently at index 0 and replace it with that. So Cassius is gone. It's going to be totally replaced by that Julius Caesar. And then again, our for in, or for each syntax, whatever you want to call it, still works on the array list. Now, you may be wondering, how does an array and then this random array list that's like completely unrelated to arrays know how to use this for each syntax? And that's because there are things called interfaces in Java, which we'll learn about later, that allow you to effectively adhere to a certain contract. And if you adhere to that contract, certain things in the language just magically work for you. And it turns out array lists happen to adhere to the same contract as arrays. It's weird, but they do, and it's a really powerful feature. So if I take this, I'm going to just close it. I want to run this one to show you how it changes. Let's go ahead and go into the collections. We'll go in here. We're going to do Java C. We're just going to compile everything, which is fine. You can see I have all the class functions that come up. And we'll do collections dot array lists. 3 R's. Okay. So again, let's look at that. We have our array list: Julius Caesar, Cassius, Pompeius. The first one is Julius Caesar. Remove 0. The first one is now Cassius. Set 0, so that's our replace. The first one is now Julius Caesar. And then we can go ahead and look, and it does the for each, goes through every element left in the array list, and only 2 pop out, Julius Caesar and Pompeius, because the original Julius Caesar was removed. We had 2 elements at that point. We replaced the first one with Julius Caesar. Any questions on these array lists? They're a little bit more powerful, as you could probably tell. Ooh, moving on. Hash maps. If you're going to learn any data structure in this class that's not something you're going to see, well, that's a lie. You do see it in JavaScript. It just has a very different shape. If there's any data structure you're going to learn, and you should really spend some time kind of researching, it's hash maps. Hash maps are incredibly important. And out of all the data structures that I know of, it's probably one of the ones I would use the most on a daily basis in any scenario. They're just extraordinarily useful. So hash maps follow kind of a similar rule to the array lists, but the underlying data structure is a little different. So we have those angle brackets again to denote types, but now there are 2 types. There are 2. The first type is the type of the key. The second type is the type of the value. Hash maps are a key value store. Okay, So basically what that says is you can put in any arbitrary key of any arbitrary type. Java is going to do some magical calculations under the hood and to determine a very efficient way to look up that key, and then you can associate a value with that key. And hash maps are powerful because they have a very fast lookup time, right? You can only put a key in one time. If I put in Caesar as the key, and I try to put in Caesar again, depending on the hash map implementation, I'm either going to get an error because it's going to say you already have that key, or it's just going to overwrite the original value I put in there. Now, a bad one is going to just let you overwrite the value because you don't really understand what's going on. A good one is going to throw an error and say you cannot do that. You'll have a different sort of function for overwriting the key. But that's just a note. You can only have the same key in the hash map one time. Now, this is very similar to a specific structure in JavaScript. Does anyone know what that is? Think about something we use every day in JavaScript where you have a key and a value. And you can only have the key one time, and you can have it associated with any value. What was that? Object? Who said that? Objects. Objects are hash maps. They're really crazy implementations of hash maps, so they're extremely powerful in JavaScript, extremely so. That's a great guess, because that's absolutely right. What you can do with the hash map is you denote the key type, you denote the value type. We're going to go ahead and put the key in. We're going to put a value in. If we go ahead and get Caesar, we'll get the value out. We can go ahead and print that, get our default. So get our default basically says if this key does not exist, give it a default value instead, so we know, so it doesn't just explode. If I try to do get up here on Cassius, literally Java will explode. It'll say that is not a key, this does not exist in the hash map, you suck, right? Maybe not that aggressive, but it'll say something like that. But here we can say, go ahead and try to get it, and if we don't have a value, give us something nice instead of just exploding, because we don't really want that. And right here, we put Cassius in, and we can go ahead and do a for each. Does this look familiar? It's very similar. So Java has this new thing they added recently called lambda functions, which are very similar to the arrow functions in JavaScript. They're a little less powerful in Java, but they added them to add some flexibility to Java. They're far more powerful in languages like C#, and they're even more powerful in languages like JavaScript. Lambda functions exist in Java, and that's well and good. It only took Java like 20 years longer than every other language to do these, and that's part of why Java sucks. It takes so long to do anything useful, and it's an incredibly verbose language. Anyway, it goes. It'll go ahead and it'll pass in the key, and it'll pass in the value for each pair in the hash map, and you can do what you will with those with this for each. I can go ahead and I can go and run this really quick. Hash maps. So our first console log is this Cassius. Cassius does not exist. Get a -1. Go ahead and we're going to get each element out. So we have Caesar with a value, a key value of 100,000, and then Cassius with 95,000. Last thing we're going to look at are conditionals, aka our if-else blocks in Java, and how they are slightly different, effectively the same thing. But remember, we don't get truthiness checks in some of the other hacks that we get in JavaScript. So the basics are the same. You have parentheses, you have an if, 4 is less than 2, which it's not. It won't print. Else if math random times 10 is less than 20, which could potentially happen, it'll print this. Else, this is our default case. You'll most likely get this. So again, you can have this style, which has no curly braces, or you can have this style, which has curly braces around them. The only rule I would follow is don't mix the two. So if you have curly braces around your if, make sure it's around your else if and your else. If you don't have curly braces around your if, make sure you have curly braces or none around all of them. Just don't mix them. But you can do either or. They're functionally the same. But only for one line. If you try to do no braces on a multi-line statement, good luck. You're going to have a lot of fun with that. And right here, braces are optional in single-line statements. And these are single-line statements. They directly follow the if, else, if, and else. It's okay to skip the braces. Some people think that that's a major drawback and you shouldn't be allowed to skip the braces. I personally am a fan of this shorthand no brace syntax. Some people say, hey, if I add a second line in, I got to add curly braces. Yeah, how long does that really take? How lazy are you? So again, personal preference. We pull in the scanner. We're going to go ahead and we're going to check the scanner. When we get stuff off of the standard input, we can actually check if there's something coming up in the scanner before we try to pull it out. Because if you try to pull something out that doesn't exist, Java will explode. You'll notice I've been saying Java explodes a lot. And that's very different from JavaScript, which explodes, but not as much. It's because it's a statically typed language. You have to be much, much safer in everything you do, which means you inevitably write much, much more code, but you inevitably have far less bugs. So, or far fewer bugs. Sorry, my grammar is bad. So there's trade-offs, right? You get fewer bugs, but you write more code. What would you rather have? Again, as I said, my professional experience has told me that writing more code up front to prevent these bugs later is a good thing. So it's quite okay, in my opinion, to write more code to prevent you from writing stupid bugs that you'll inevitably write because we're not always 100% paying attention. You know, sometimes we're just writing code and going. But anyway, you can see these return Boolean values. I can actually hover over them, and I get this little IntelliSense thing that tells me java.util.scanner.hasNextLine returns a Boolean value. Tells you exactly what happens. Throws a legal state exception if the scanner is closed. So that's a totally different thing altogether. Basically, if these are true, and it is true that we have something on the scanner input, we can go ahead and pull it out. Otherwise, we don't have to worry about it. Any questions on conditionals? Ooh, we're going to spend a little bit of time. Let me see where the time's at in the lesson plan. Question for the class. Would you rather do an activity right now for 15 minutes, then break, or break, then come do the activity? Break? Okay. Break 15 minutes at 8 o'clock. We'll start the next activity. Trent, we slack out. Number 4. Or, never mind. They have it. The next activity is number 4, student array maps unsolved. Go ahead and start it whenever you want. Got to be done by 8:15 effectively.
Probably and like I really like the role of and one of the reasons why more like a software developer versus developer expect you to have some so it's hard because you know the game probably the best part of the job is around more
Yeah.
I mean, it is a big thing that like arrays in Java. Okay. Like if you define an array and the size and the size, add each index of that array. You can't just get rid of index of that array altogether. You have to copy over all those elements and stick them in a new array of that new size minus one. And you start running and should run an array custom does for you. When you work with arrays, oh. But it's not unhappy about that.
What's the whole paradigm behind the noding? Yeah. Compared to how Java runs, it's like totally different. So I think Java, a Java-based server computers is the one, and the other one, how they. There's so many different ideas. And so that's a bigger. I mean, Java's additional stuff. So the easiest. You're working about it. You're trying to go. Pretty much right. No, whatever you prefer. Just like on the web. No job.
That's part of the JRE, but JD, Java C is part of the JDK. So it's trying to have
I think it's a burger. All the time it's immediately. And I think that was more. And I think. Okay. Fit myself and I guess because you're on the I haven't played Cool. It's curious.
And the people that basically
But yeah.
what do you think?
Yeah. Yeah. And it's like,
I think there's like two errors.
there's where, yeah.
Routing. Yeah. Yeah, and it's like how we should probably be designing our own projects. Yeah. So I base it off of activity 11, where it's like the path is like all broken up on the API put together. Goes through like 5 files.
That's what I did do. Like,
Yeah.
but then I
Yeah. Well, and it's like, it's, like, I would say, I guess, like, maybe do what's valuable for you.
yeah.
Like right now, mine, it's literally the HTML, like 1995 HTML, styling what's and it shows the original names. And I'm like, I'm gonna.
Yeah. Like for right.
Well, I'm gonna complete the homework, but like, if I was just in it to like get that routing figured out and like really understand it, I might do like a couple more routes and then do like, okay, cool, good enough.
Yeah. If you have other things and like you don't like the and competition.
React router, actual router, and how those two interact, all that stuff like that.
You don't get a high five. That you get. Ooh, I don't know.
Look at a silver star.
Ooh, yeah. I can color. I'll go 5 minutes. Sorry.
I would spend the rest of the time working on the next assignment. I slacked out the name of it for you all.
Actually, I like the G.
What's up?
I can't even get that Java C thing to work. Maybe I'm saying, I don't know what you're talking about.
That's okay. This is very different and it has no consequence on the rest of the class.
Thank you.
So,
But I tried doing that.
okay.
I thought maybe I was in the wrong file or folder, whatever.
You're trying to Java C in the wrong folder, that's for sure. So if you hit LS, so the Java C looks for .java files and you don't have any.
Oh, I have to go in the unsolved folder.
Yep.
To that one. No.
I would do LS again just to make sure. So you gotta go to console. Now I would do LS again. Make sure. Now your Java C should work.
So she needs to be the console IO Java thing.
So the Java C star.java and it'll compile it. So if you hit enter, then you hit LS. Now you have a .class file in there too, and that's good. So now if you want to run it, this is where you do Java. Yep. So something didn't quite work because it did nothing. So what is the file you were trying to, if you go to unsolved, let me see the file that you're supposed to edit. So it probably just doesn't have any code in it to work right now. So open that console.io.java. If you scroll down, we'll see if there's anything even in there. Yeah, so yeah, it works. There's just nothing to do yet. So now you gotta add the code or to do what the assignment says, right? But you got the compile to work.
Okay, so
Compile, then you add.
do you have to do that for every folder?
Yep, and every time you make a change.
And then make a change, you gotta do.
Every time you change the code and you do Control S and save, you'll have to do the Java C and then Java CP, whatever again to make it run.
That's a really bug.
So we're doing it manually by hand, so yes, it is. But normally people do this stuff, especially with Java, from what's called an IDE, integrated development environment, and it has a lot of tools built in for you. So while it's still manual, you usually just press like a button and it does it.
Oh, I see.
So generally it's this. Or you build like a fancy script, then you just run the script and the script will do everything for you.
It's like Nodemon, kind of thing, where they just keep running it for you.
Kind of. Nodemon's good because it like builds and then restarts the service for you, but you can't really do that with Java. It doesn't work the same way. They're not equivalent at all. So there's stuff that you could potentially have it rebuild for you, but if you're in the middle of doing work, you may not want it to rebuild yet because it probably won't build. So
What's
usually,
the point of Java? I mean, because I remember Robbie saying that most, like 95% or 98% of your websites are going to JavaScript.
a huge amount. The front ends are almost always JavaScript. But the front end, Java cannot work in the front end of a website, but it can completely replace the Node backend if you wanted it to.
Java, good.
It's server language. The point of Java is it's just another tool to get stuff done. Some people use Java, some people use Node, some people use .NET, some people use C++. Depends on a lot of things. Your environment that you're in, what you started with. It's just another tool to get the job done.
What you're familiar with, maybe?
A lot of big enterprise uses Java. That's really the last bastion of Java. Smaller companies generally don't. They use things like Node. If they're more into the enterprise stuff, they'll use .NET, but like Node, Python, those kinds of really quick iterative languages are bigger in smaller companies.
And I don't know what to say myself.
They're pretty easy to pick up once you get your JavaScript down. It's not that big of a deal to jump to something like Python. Java is a bigger deal though. It's very different.
Java is?
Java, yeah. It's very different, and then there's other languages that are even more different that are even harder to get. So, the nature of the beast.
I can just stick to the easier ones that I still don't know.
I wouldn't say they're easier per se. They're just what we've been learning. You've been learning Java from the beginning. Node would be the weird one. So.
Which one? Okay.
Okay, so this was a particularly tough assignment as well. I mean, I suppose all of them will be today, but this one has a very unique type you have to use to get the job done, which isn't so intuitive unless you're familiar with typing. So the idea was you're going to have a list of students effectively, and you need to ask for information about the students, and it's going to, you can imagine it's like a JSON blob of data, right? Where you'd ask, what's the name, first name, last name, and you have to store these in some sort of data structure so you can get these keys out and get the values out. But how do you do this in Java? Because you effectively have unlimited number of students, right? You can continue going. So the type you're going to need to use is an array list because you need a list of students with a hash map of type string string. Anyone have a guess as to why we need that type? Why we have to use that type and not something else?
Stuff that comes off the console.
Stuff that comes off the console is a string, and we're referencing it by some string as our key, right? Exactly. So basically what we got is that crazy type right there, and then we have a while loop that goes on forever, as long as we want it to. For each new student, we're going to create a new hash map of type string string. You're going to go ahead and get the name. If there is a name, you can put it in the hash map with the key first. Same with last name, put it with the key last. Middle initial, put it the key middle initial. Address, put it the key address. Email, put it the key email. Phone number, put it the key phone number. And then for each student, you can print out what their data looks like. So first, last, middle initial, email, phone number, address, all of that stuff right here with the for each. And then, is this information correct? If the answer is not Y, so if it's anything but Y, then you get to go ahead and to continue, kind of like we see it in JavaScript. We'll just jump us to the next iteration of the loop. In this case, it's going to restart that while loop, and we're going to do it all over again. Otherwise, in our big array list of students that we have way up here, we're going to go ahead and add our new student, which is that hash map, right? So you can look at the types here. Pretty crazy. Set the confirmation to nothing. Would you like to add another student? If so, we can go ahead and continue the loop, right? If not, we're going to go ahead and loop through all of the students and then break. Kill the loop. So this one was really tough. There was a lot going on here. I would be surprised if anyone finished. Did anyone finish? I'd be really surprised if anyone did. That'd be pretty crazy. Because there's a lot going on. Definitely a lot going on. Just typing this could take you, 5 or 6 minutes, right? So thinking about it too, trying to solve it is crazy. But are there any questions on this? I know we're. Yeah, you want to look at this type?
Yeah.
Crazy, right there. So the funny thing about generics is, well, you can put anything in them, right? So an array list can effectively hold any type, and a hash map of type string. String is a type. Yes, you could have an array list of a hash map of type string, hash map of type string, of hash map of type string of string. And it worked just fine. It's just remembering what you're doing with those types would probably make you want to die. So it's not recommended you make such complex types, or if you do, you wrap them in some sort of abstraction, such as another class, that can kind of take away the hard work for you guessing what the type is. Does anyone else want any more explanation on this or to see some of this code? I'll go ahead and have Trent Slack it out so you can look at it later, because this one's pretty crazy and copying it down is going to take forever. So Trent can Slack out the solved one there. We're going to take a look at functions real quick. Okay. On to functions. There's a lot you can do with functions. Instructor note here. Don't worry about that. I'll go over it. There's a lot you can do with functions in Java, but they're slightly different than JavaScript. So one of the big things is you can't just willy-nilly define a function wherever you want. In JavaScript, you could do const x equals some crazy function, right? And then you could export that or just call it wherever you want it. Whatever. Functions of a value in JavaScript. Functions are not values in Java. So when you have that kind of relationship with functions, like we do in JavaScript, where they can be values, it's called functions as a first-class citizen, right? Because they are treated as values. You can use them as values. You can use them as inputs to other functions and stuff like that. They are not first-class citizens in Java. They are functions. They are treated like functions, and that's it. You use them in a special way. So they're very restrictive in that regard. Most modern languages treat functions as first-class citizens because we found over the years that having higher order functions and stuff like that, which are basically functions that accept functions or functions that return functions, are extremely powerful. They allow for very, very terse and robust code in lots of ways. And Java doesn't allow that, but Java did add those lambda functions we showed earlier with the little arrows. Those are effectively addressing this problem, but only so much because Java can't actually change its underlying implementation to fix that. So another reason why Java kind of sucks. There's a lot of things they just can't do because it's Java. And if they change it, they break a bunch of old stuff, and they don't want to do that. So we have a class called functions. But one of the things you'll notice is every single one of the functions in this class called functions is prefixed with the static keyword. Some of them, static's in the wrong place even. And I don't know that it actually matters. I think you can do static public or public static. Same with private. But the reason that we're making these static right now is we don't want to get into class instances and like how all that stuff works. We're about to do that in the next segment. Basically, like I said earlier, when you have a static function, it only exists on the class itself and not on the instances. So if we wanted to call this, we could do function.printName, function.multiply, function.printInput, something like that. And you can actually see down here, they're just directly referenced inside of our static void main function. Right? This is the entry point to the functions application. They're just directly referenced, and they're static, so you can do this. If they weren't static, you wouldn't be able to. So they're static to make it easy for us to test in this example. So we have a print name, which just takes in a string name, goes ahead and formats it into another string, and prints it. We have a multiply, which takes in two doubles, multiplies them with the little asterisk there, and returns another double. Print input takes in a t. Well, that's interesting. What the hell is t? T is a generic type. So you can specify generics in your functions. And this is an example of how you would do it. You have these little angle brackets with t, and your input is of type t, and you can do stuff to type t, but you actually have no idea until you run the program what t even is. And that is the beauty of generics in a typed language. In JavaScript, we could just pass any old thing into print input and print it because JavaScript's magic and dynamic and just does whatever it needs to do to make it work. Java is not so simple. You can't just pass whatever you want into a function and have it work. You need to give the JavaScript compiler some rules to follow. And in this case, we're saying anything does work. And Java knows how to handle that. And the reason it knows how to handle it is because everything function, which basically converts it to a string, right? However that's implemented. And so since we know that, we can always call this safely, and it's never a problem. Now, that's not totally true because you could pass in null here potentially, depending on what t is, but that's an aside. Basically, everything has a toString, so it's okay. It doesn't matter what it is. So this is a function that accepts anything. Get password. Now this one is different because it has private in front of it. Private means you cannot call this function except for from inside of the functions class. So if I had another class that referenced functions, I could not call get password. Not at all. I don't have access to it. It is private to the function. Public, though, on the other hand, get username, I could get that from wherever. And it makes sense. You don't want to expose your password to everyone, but your username, that's generally okay, right? You need a reference to be able to find someone or whatever. However, you can see get password works just fine from inside the functions class because it belongs to the functions class. Private, functions owns it, and this static void main is also part of functions, so it can access it. And the print input function, which prints literally anything, you can see in my little IntelliSense that's popping up, it can tell you what type it is, type string here in those angle brackets, right? So print input takes anything. In this case, we know because we're passing in a 2, it's type integer. In this case, because we're passing in fish in double quotes, it's a type string. In this case, because get password returns a string, we know that the input is type string. So you can see the return type right here, which is right before get password, is of type string. Print input takes type of anything, T. Print input of get password there has to, therefore, take in type string, right? No way around it. Multiply, print input, has to take in a double. Multiply returns double. You see double. These are 2 doubles or ints or whatever, but they're doubles in this case. Takes in a double. Print name, again, this one does take in a concrete string. You can see from the signature, print name takes in a string name, get username returns a string. It's the gist of functions at a high level. Any questions on functions? No? Everyone's a function master? Cool. Well, we're going to spend 15 minutes doing exercise 6 student functions in the repo, the unsolved one. Go ahead and do that. Make sure that all of your functions have static in front of them or it won't compile. Java-C won't work. You can go ahead and try it and see what happens, but it's probably going to blow up. Nope, this is it. It's my last day. Supposedly. As far as I know. What? Yeah. Who knows what he's doing? I don't know. Bad things, I guess, huh? Hopefully he's having fun doing whatever it is he's doing. can't figure this stuff out, or today seems really difficult and you don't want to apply much effort to it, that's fine. You really have no consequence on this boot camp. So, you know, I'm not your instructor saying give me advice, but if you're interested in learning more about Java and these other types of languages, these are good exercises to keep your hands busy. And there's a big wide world out there. Like I said, I prefer .NET, but learning the stuff you've done here in Java, you can apply a lot of it to C# is very similar. So there's that advantage. Tons of jobs with this kind of stuff. But if you're like looking at this and like I really have no idea what the hell to do, I don't even want to try. Yeah, I don't think anyone would be hurt by it.
Yeah. If we maybe just do it together.
You just want to do the exercises together? That
Staring at it for like 6 minutes, not doing anything.
we can totally do that, yeah. Is anyone opposed to us just doing the exercises together? that is a great suggestion. I probably should have thought about it in the beginning. Huh? All right. So this solved one I'll just pull up, but we'll do the unsolved of the last one together because that one is arguably the most important one. So this functions, I think this is the functions one. Yeah. So the point of this functions was basically to take all the stuff we've done so far with all the crazy like console output crap and turn it into functions to make it a little bit more modular. And they did that. This one was another tough one. So there's a few things we want to do. When you're taking your code, and we know this a little bit from the JavaScript we've done, and you're trying to decide how best to reuse code, you generally put it into functions, right? That's what they're for, right? They're reusable components. So one of the first things we have multiple times is confirm. How do we know if someone's saying yes or no? We can easily encapsulate that into a single function and just run it over and over again. And you can see, actually, that's what they did. If I go look down here, there's just confirm called, confirm again, just passes in some input. So let's look at how they constructed this function. Yep, you have a question? This is 6. This is the function one. So what are the two things you're going to need for a confirmation, right? Well, we need to get input from the console. We need to get input from the standard input to determine what the user is typing to us. And we need to give them a message. So we can ask them, hey, do you want to confirm something, right? I don't know what the message is. Could be literally anything. It's a good way to think about it. So we have our confirmation, and this is going to be the return value from what the user enters in, right? We're just going to go ahead and do a string format with that %s and ask y or n, yes or no, and print our message. So this is our generic confirmation message, right? Whatever you put in here, whatever question you want, it's going to be followed by a yes or no, and hopefully that's enough of a context clue to the user that they'll give you a y or an n. Sometimes they'll give you a 1 or whatever, and they're just being a stupid user. So it happens. But anyway, after we print out the confirmation, we know that we're expecting input from the user. So we can go ahead and tell our scanner to determine if we have any input. And if we do, we'll grab it as a confirmation, and we're just going to return that confirmation and hope for the best. Now, one way we can make this better, we'll go over in a little bit, is to actually have it return a Boolean of true or false. Did they confirm? This is actually kind of a halfway implementation, if you ask me. Let's go ahead and look at the original function and see how they started doing this stuff. Actually, that'd probably be a better approach as opposed to just jumping into the function. So we have our scanner, and we have our crazy array list hash map crazy thing for all of our students, right? One thing we're going to have to do several times is we're going to have to re-instantiate that hash map object, and it's got a crazy type, and doing that kind of sucks. So why don't we move that to a function? And we did. We moved it to a create student function. Again, it's static because it needs to live inside of this functions class, and we're just going to return a new hash map. We can call this from anywhere now. It's pretty reusable, and you don't have to worry about the types or anything crazy like that because they're already defined for you, right? So we call create student right here, and it gives us our hash map. Voila. We have our keys. These are all the things we're going to be looking for from the user input, right? First name, last name, middle name, address, email, phone number. And for each key, we're going to go ahead and prompt for input. So this is another great use of function. There's a ton of different instances where we need to say, do you have this? Yes or no, or whatever, get something from the user. So we can go ahead and encapsulate that into its own function. My God. That up here. But it needs a ton of stuff. It needs our input, it needs our current hash map, it needs the key we're asking for, right? So what we're going to do is format a string. Please enter the student's key. So if we go back to where this get next is implemented and look at the keys that are passed in, first name will be the first one. We have our scanner, we have our student hash map, and then first name comes on in, okay? So please enter the student's first name. That's our first key. If we get an input line like we're expecting, we can go ahead and put it at the first name key in our hash map, and we're good to go. Why does this function have a return type of void? Because it does stuff, but it doesn't return anything. That's absolutely right. There's a side effect here, and that is our hash map has been changed, but it doesn't actually return anything, so there's no reason to have a return value, which is good. It makes it really easy to kind of work through that, right? And so we just do this for every single key. What's the student's last name? Get something. What's the student's middle name? Get something. What's the student's address? It's a pretty generic function. It does one thing, and that is gets a new line from the standard input, but that's easy. It's easy to encapsulate that into a single function and call it over and over and over and over again, right? So our keys are done. We've asked for the phone number. They gave us a phone number, and we're good. We can go ahead and print everything out like we did before. Nothing fancy here. This is our hash map. We do a for each. We'll get the key. We'll get the value. We can print them both out. The student's first name is Joe. The student's last name is Smith. The student's middle name is S. I don't know. Whatever we put in there, it's going to print them out. Then we can go ahead and we can add our confirm input. Is this information correct? We go ahead and we get a confirmation. And so I said this is kind of a half-baked confirm though, right? Because it returns a string. And there's something we have to do after every single time that's really kind of irritating. Why didn't they just put this part into the function? That doesn't literally makes no sense. I have no idea why they did that. Because if you have to repeat functionality over and over again, it makes sense to put it in a function, right? So we can go ahead and actually change this confirm signature that returns a string right now. Oh my God, there's so many of them. The word confirm is way into. And let's use a Boolean instead, because that makes more sense, right? Confirm, yes or no. I think it makes more sense. What do you guys think? Yeah, I think so. Then we can just return that. Now that whole set of functionality that we were using is much simpler. The other thing we can do, instead of just saying confirm, which is kind of a bad name, we can do something like has user confirmed, which returns true or false. We replace it right here as user confirmed. And then we just need to do if not confirmation. As user confirmed. I feel like that's a lot simpler. What do you guys think? Yeah, makes a little bit more sense, right? So when you're taking things and putting them into a function, it makes a lot of sense to try to think about the stuff you're reusing and how you can put that into one place so you don't have to do any extra work. We want to be as lazy as humanly possible. That is why we're developers, right? There's a ton of stuff in this world we don't ever want to do again, so we write software to do it for us. That's literally our whole job. And so when you're writing your code, you want that to be the case as well. You want to write your functions in such a way that you can be literally as lazy as possible and not have to worry about it. Because the more work you got to do, more likely you're going to get bugs. You're going to mess something up. What if you didn't use the ignore case or whatever, and you just did an uppercase Y, and they give you a lowercase y, and you want to count an uppercase Y? Well, there's a bug, So it's a good idea when you're really deciding what needs to be a function to really think about everything that has to do with that piece of functionality. So anyway, if we don't have a confirmation, we can go ahead and say, try re-entering the student's information. We can just do the input next line. And what that does is it says, hey, input, just destroy everything we have. We don't care about anything else. We're going to set it basically to empty and run a continue, which takes us all the way back up to this while true. Otherwise, we're going to go ahead and add our new student. We're going to get another confirmation. If we get that confirmation, we can go ahead and throw away the input, and we can add another student, right? Because we want an empty scanner. Otherwise, we can report the students, which is going to loop through all the students in our list and print them out, and then we can exit the loop. So let's look at report students. Takes in our crazy array list hash map string thing, and for every hash map in students, we can run this student for each list, right? Which, again, we've done that once, haven't we? So maybe we can make another function. Static void print student info, which is going to take in a hash map string student. Print that right there. They're giving us this exercise on functions, and they don't even make all the functions. I don't get it. Come on, guys. Print student info, our student right there. Look at how much cleaner that is already. And then we can go right here where it's done literally again. So much more elegant, right? It's now, I just got rid of like literally 7 lines of code, and I did almost no work. Maybe not that many, because if you look at the total function declaration, it's 5 lines, right? So I got rid of 5 lines here, 5 lines there, replaced them with 1. So yeah, okay, a few lines of code, right? Not that many, maybe like 4 or 5. But either way, print student info is very consistent. We want it to be consistent. We don't want to mess it up anywhere. So we might as well just wrap it in a function. Call it again. That's the essence of this exercise. Anyone have any questions on these functions? How they work? Stuff like that? Cool. All right, well, we're going to look at classes, which is the last thing we're going to do today. And it is arguably the most important, like I said. We'll see how they're different from JavaScript. And we will also see why they're so important in Java. So first things first, we have a user class. So say we have, any sort of database system, or say we have our website, right? And our website has the concept of users, and we want users to be able to log in with an email and set up a username, maybe one day have a password, all those things that you're going to need for a user implementation. This might be a representation of that user. And there's quite a bit going on here that we have to cover. As you can see, this thing is pretty big, okay? So first things first, we define our package, which is classes. Again, we have a folder classes that this is nested in. It's the way you need it in Java. It just is what it is. The second thing is we have our public class user definition. And we'll get into these access modifiers a little bit more here. We'll see what happens if we don't have public, and we'll kind of try to break things a little bit. So the first variable we run into is a S users created. Interesting. Private static int S users created equals 0. Why do you think it's private? Why do you think it's static? Anyone have a guess? Well, there's a couple of reasons. Static, because if we're trying to count how many users are created, if we were to make this non-static, wouldn't that mean that every user we created would have its own count of users created? Which means that every time we created one, it would just be 1, and we'd never actually know how many were created. But if we keep it as static, we can tally this number. We can increment it every time we create a user, which you can see right here. And we can have a literal count of how many users we've created. Private, because why does anyone else need this information? So when you're thinking about private versus public, the question to ask is, does anyone else really need this information? The answer is almost always no. And you should really think about that question before you make anything public or private. The answer should almost always be no. Your classes should probably only have a few things that are exposed to the outside world. And those are the really important things that have to do with your class that make your class valuable outside of itself. But the point of a class is to take all of this magical code you're writing and hide it. Hide it behind some sort of a noun, right? Some sort of an abstraction, as they say in the programming world. And the idea is you have this encapsulation. You're encapsulating all of this logic behind some abstraction so that the consumers of your user class don't have to think about what the user actually does. The point is, when someone's using a piece of code you wrote, the best code you could ever write is code that makes them say, I know exactly how this is used just by the function names or the class names. I know exactly what I need to do to use this. If someone can read your code and just say, I don't even need to look at what the user class does, I can just do new user, blah, 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 and start using the user, you're successful because your code is very well defined, very well named, and simple. So the point of private is, does anyone else need this info? The answer is almost always no, and you should make it private. The answer is yes. You need to really ask yourself why. Is it yes, first of all? And secondly, you need to make it public if it's actually the case that it should be public. Now, one thing they're doing here, which I am going to tell you right now is a really, really horrible thing to do, is they're prefixing this with S. And they're prefixing it with S because it's supposed to be static. And for some reason, some really dumb people a long time ago decided that that was a good way to signal to someone using the variable that that's static. But if you're too lazy to scroll up like 4 lines, well, then you don't need to be writing in my code base. So don't do that. It's called Hungarian case, where you would prefix it with like an M for module or something that means like it's private, right? Or a G for global, which means it's a global variable, or S for static, or even like an I for integer or something. That's just stupid. Our tooling is so good these days, you don't need to do it. I can literally hover over it, and it tells me it's an int there. I can hover over it right here. Well, the fact that it's coming off of user shows it's static anyway. So I can't hover over it and see that it's static here, but if I was using a real IDE, I probably could. And see the definition, there's literally no reason for me to even look at it. So having the S there is a terrible, terrible practice. And if you go anywhere and you do something like this, you'll probably be shunned. So don't do it. Why they have it here, I don't know. I'm ranting on it pretty hard, but it is bad practice. So anyway, that's private and static. How do we feel about private and static? How do we feel about static? Right? We all get that means that there's only one instance of that variable, one instance of that function, one instance of that class, right? It only exists once in the code base. Private, no one else can get to it. And we'll see, I'll try to call this from somewhere else because we're getting into other multiple classes, these private things from another class, and you'll see that Java just explodes. It's like, dude, that doesn't even exist. What are you trying to do? So, some more private stuff. Our username, we want that to be private because we don't want anyone to be able to just willy-nilly overwrite variables, right? So we have a private username, a private email. The user, these things are important to the user, right? When we create a user, we need to give them a username and an email address. We don't want anyone to have the ability to use permission. If they do, they could ruin the integrity. You know, imagine if there was a database and you could just log in and be like, I'm going to log in as Joe today, and I'm going to change Joe's username to Frank because I feel like it. That's exactly what this is equivalent to if you were to make these public. I could just do whatever I wanted, and that's kind of dumb. So this is, again, private. Does anyone else need to know about this? The answer is no. They should not know about this. There's other ways that we can tell them about these things without letting them change it or actually getting access to the variables themselves. So private, again, and they're both strings, username and email, which makes sense. So we have this fun function here, and this is our constructor. We all remember constructors from JavaScript. Constructors are special functions, right? We would capitalize them because it makes us feel good. In JavaScript, we don't really need to. But the important thing to note is when we have a constructor, it changes the prototype and how it works. And it also needs to be called with new in front of it. That is absolutely the case with constructors in Java as well. They're a function you're basically calling new in front of, and it creates a new instance of that thing. Just like in JavaScript, you call new in front of a constructor function, you'll get an object back, right? Your variable will be an object. In this case, when we do new user, we'll get a user back. Now, they're type strict to Java, so that variable is going to be of type user, which is really easy to work with. but it's essentially the same. There are no prototypes in Java. Those things don't exist. That's a wacky construct in JavaScript that, I don't know, some lunatic came up with someday. These have real class implementations. These are real classes. They are exactly as you see them. Everything you put here is what's in the class, and that's it. There's some helper stuff that you get in Java, like toString and stuff like that, equals and stuff, that just everything gets. But those things are pretty basic, right? And you can change them from the class if you wanted to. But there's no crazy prototype, no wacky stuff you can do with that. This is just the user. So we go ahead and we have this user constructor, which by default is public, I'm fairly sure, in Java. So when you don't put anything here, it's public. You could make this private, though, totally. Have a private constructor, and we can talk about that later. But it takes in two things. It takes in a string username and a string email. And it calls these functions, set username and set email, which we can see down here, are private functions. They take in a string username, they take in a string email, but they're both private. They don't return anything void, and they just set those variables. So here's a fun question. Why might we have private functions, set username and set email, that literally only set the private variables, username and email? Is there a real reason to do this? Does anyone have any guesses why we might? So there isn't actually a real reason to do it. Obviously, this .username equals username still works because those are private variables and those are private functions. The only reason why you might want to do this is, say you want to do something to the username before you store it. So say you always wanted to guarantee that the username was lowercase before you assigned it to that variable. You could do something like in this function, .to lowercase or whatever, right? And you can always guarantee that's going to happen. So that's nice. But if you're just going to do the assignment and everything's private anyway, it doesn't particularly matter that you do this. It's just a nice convention that you could. Mainly, this was an example of them just showing more function stuff, right? So this email, this username, they're private. We said no one can change these unless we give them explicit permission to do so. And right now, the only true pathway we know for setting these is through the constructor, which means when I create a new user, I'm giving the username and the email, and they're not changing. And that absolutely is the case based off of what we have here in this user class. But we're probably going to need to see the username and the email some way. The user is kind of useless if it's literally just a totally private class that you can instantiate. Not a whole lot you could do with it other than say, whoa, great, I have a user. So how do we get those out? Well, we create public functions that return the type we want. So in this case, string, that's going to return the value of the username. So you can't change this. No one can do .getUsername equals something, right, and change it. Can't do that in Java. So this just returns the value of the username, but doesn't allow anyone to change anything. This is the way you circumvent those privacy rules, right? People need to still see this info, but they can't change it. So we'll create some public getter functions. These are called getters and setters. We'll create some public getter functions so we can return those values, and everything's hunky-dory. People can now use it. We also have a cool helper function called introduce that we can use. And so for a user, you might want to say my username is whatever, right? My email address is whatever. Maybe we have another function, give email, and we can give it to another user or something like that, right? My email is whatever. And so this is a nice helper function, belongs to the user. Now, why isn't this static? Anyone have an idea? Yep, so you're both right. Basically, individual users have a username, right? Not all users. All users don't have one unified username. And so those instances need to be able to introduce themselves separately of each other. And so it can't be static. It could be static, but this .username wouldn't make any sense. You couldn't do it. It just wouldn't really work because you'd all be, if you wanted to use a username, you'd all be overriding the username every time you created a new user. Get count, though, however, is static because we want to see our S users created, our total users created, right? Our static count. So that has to be static because that's a static variable, and you can't You could get to it, I guess, but it doesn't really make sense to have like a non-static version of get count that just returns a static value. I mean, you could do it, I guess, but don't really need to. So the other thing that's in here that I haven't really discussed is this. And we're familiar with this from JavaScript. It's similar. It's just a little bit more sane in how it works. This actually refers to this. You can access everything that's in this file, and that's it, right? It's just what's in this file, that's this. There's no crazy prototype. You can't overwrite stuff. You can't like add functions to it and like do crazy things. There's no binding context and functions. So this inside of get username and this inside of set username, it's the same this. And if you returned a function inside of those or something, which you can't quite do in Java, but say you could, this would still represent the class. It wouldn't represent some weird function because functions can have their own binding context in JavaScript. So there's no funky wackiness to this. It's just literally this instance. This does not exist on a static class, right? In status functions, there's no this because there's no instance, right? So this is specific instances. I'm still confused about what I mean by instance. We're going to look at that in just a moment. But when I say instance, does that make anyone go, I don't quite know what he's saying with instance, so I'm kind of leading you astray because I don't want that to be the case. No? We all know what an instance is? Cool. Okay, I'll reiterate an instance. So I will actually show you because the next file is going to have it. This is an instance. Remember in JavaScript, you have a constructor function. I said you preface it with new. Same with constructor in Java. We're using our user class, and we're creating a variable of type user called Jim. Jim is an instance of the user class, okay? You need to use a constructor to get an instance. Calling user.getCount, that's calling the user class and calling a static function on the user class. But user itself is not an instance, okay? Does that make sense? Is that enough clarification, or should I get should I come up with a cool metaphor for it? Yeah, does that make sense? Everyone jive in on this instance declaration, this instance definition? Basically, if I want an actual user, I need an instance of it. To get an instance of the user class, I need to prefix that user constructor with new, and then the return value of that new user function is an instance of that user, right? It's typed as a user. We're calling it Jim. That's the variable name. And then remember, we have two parameters in that constructor. First one's the username, which is Jim. Second one's the email, jim@wonderland.edu. So jim.introduce. That's a public function that just prints out, hello, my username is Jim, or my name is Jim. And we can go ahead and look at this. Look at these side by side. And I might make it a bit nicer. I'm going to scale this down just a little bit. Is that too small for anyone? Okay. Let me know if it is. So anyway, we create a new instance of Jim. Let's look at our constructor. This username, this email, right? And then we're incrementing that user's created count, that static count. That's what this is. New user, right? Jim. And jim@wonderland.edu creates a Jim instance. And we want to call Jim.introduce. We want to print through the command line Jim's username right here, public. I get to it. We literally cannot call Jim. I cannot type. Oh my gosh. Jim.set email. We can't call this. I get an error right away. And here we go. This is actually telling me the appropriate answer. This method, set email of type string from the type user, is not visible. It's not visible because it's private. Visibility is kind of the word we use. The private access modifier makes set email only visible to the user instance itself. So inside of Jim, deep in Jim's heart, he can set his email to whatever he wants. However, outside of Jim, I can't change his email. That's up to Jim. Because it's private. What Dim can introduce. Oh, and here you go. The exact same thing I was just saying. This will throw an error. Java will actually vomit all over the place and say, that's dumb. Don't do that. The user count, that's public. We can go ahead and do it. But remember, we can't use Jim because it's static. If we use Jim, we'll get a problem because Jim, while it is an instance of the user class, it's not actually the user class. The user class is the user class itself. And so anything that's static has to be referenced directly from it. Throwaway here, this is just a crazy throwaway user. And if we were to print user get count at this point, user count would be 2. Reason why is we've gone through that user constructor twice. So we've incremented the static value twice. It belongs to the user class. So when we create a new user, that's not overwritten per se. You know, it doesn't belong to the individual instance. And then right here, if we were to, just like I did gem.getCount, if we were to do throwaway.getCount, it would throw because getCount is static. You can't call it from an instance. You just cannot do it. It's not the case. It's not possible in Java. Any questions on this little example? We'll go ahead now. We'll go work on the exercise. We'll do it together. All right. So let's close this functions one. Let me pull up the next exercise. It is going to be number 8, classes and objects unsolved. Open the whole thing so we can look at the README. Okay, so let's look at the README real quick, see what we got to do. In this activity, we will get some practice creating and using classes. Create a student class. It should have private string fields corresponding to the keys being used in the student hash map. Give the student class a report method that prints all of the attributes. Create a roster class. This is just a simple wrapper around the array list of student. Give it a report method that in turn calls the report method of each student in the list. Refactor your code to use these new classes and methods. Hints. Don't forget to complete this path. Okay, so let's jump into unsolved. What this is going to do, this is just like this is the last one with the functions that we were looking at, but we're going to make it slightly better because we're going to start using classes. So first things first, we're going to make a student.java. We're going to make package console public class student. Does console not have a semicolon after it? It does. Cool. We need a few different fields. Let's go ahead and open these side by side so we can see all the keys we're going to need. I don't know why it's saying that. Damn you, Java. All right, so what are the keys we've got? First name, last name, middle name, address. Gosh, this is horrible formatting. Who made this? Format these really quick so we don't have to try to squint to see them. All right, so the instruction said specifically we want these to be private. So private string first name. Private string last name. Private string address. Private string middle name. Private string email. Private string I cannot type phone number. All right, we've got our classes as private instance members. They're specifically instance members. Why don't we go ahead and do something else too, just for fun? Private static static int student count, just like they were doing, and we're going to set it equal to 0 default. Now we need a constructor. This constructor is, whoa, auto-generating for me. That's crazy. It's going to be big. But because these fields, first name, last name, address, middle name, email, phone number, what say you, are all private, we can't change them from outside of the student. So we should probably just take everything we need from the student, and we should just get it in here, right? And pass it in the constructor. You can most definitely do that. But there's a problem. We're waiting for all this input to happen, right? And it's going to be stored in the hash map. Like, if we're using the constructor and we expect all 6 of these fields, that means all 6 of these fields have to be filled out when we get them into the student, right? So how we use this is going to very much determine how this program flow changes. But we're going to do it this way because this is the ideal. So you're going to do first name, string first name, and we're going to have to do this for all of them. Last name, middle name, address, email, phone number, right? Go ahead and we're last name, middle name, email, and I'm kind of doing them out of order, address, phone number. And then the last tedious part, well, it's not the last, but this dot first name equals first name, this dot last name equals last name, this dot middle name equals middle name, dot email equals email, this dot address equals address, and this dot phone number equals phone number. Tedious, I know, yes, Java is sometimes, but this is any sort of static language is going to suffer from this kind of similar problem where you're going to have a lot of duplication in some cases, and that sucks, but it just is what it is. So another interesting thing about the this keyword is we have this first name. It is coming in as a parameter. If we were to not use this dot first name and just do first name equals first name, Java would get confused. JavaScript kind of does this too, except for if you don't use this, it just won't ever exist on the class. Technically, this also works. So if we have underscore first name is the thing we're passing in, that works. When I use first name in this instance, it says, hey, give me the first name variable of the specific student instance, right? Which is that private first name. And then we're going to set it equal to underscore first name. However, when they share the exact same name, it has no idea which one you're talking about. So if you preface it with this dot, you're basically saying, explicitly, I want the class's version of first name to equal the first name that we passed into the function. And that's how you can get around the whole parameter share the same name problem in Java, which is a problem we sometimes have in JavaScript. All right. Oh, we wanted a report function. Now, this isn't, by the way, this isn't the only way we could write this code. This is the way I'm choosing to do it. You could also pass in the hash map into the student constructor and extract everything that way if you wanted. There's like a billion ways you could do this. But I'm choosing to do it this way because it's very explicit, right? It's extremely explicit what this student is. It doesn't hide any detail. And if we wanted to expose the first name, last name, address, middle name, email, and phone number, we could with public getters, right? Public string get first name, public string get last name. This is where one of the major criticisms of Java comes in, because C# has a nice thing called auto properties, which basically means in the same line that we're defining first name and last name, we could define a private setter and a public getter without doing any extra work. In Java, if we wanted to do that, we'd have to make a private function and a public function to do our getter and setter, and it's a lot of boilerplate, and it's just a ton of code for really feels like no benefit at the end of the day. But there is benefit, it's just a lot of work, right? So Java is a little bit more tedious than C# in a long ways, but we need a report function, right? And this is going to do system.out.println. We got to wrap this in the string format. And then pass in this first name. Okay, it's kind of long, I know. I will chunk this up for you. So we're gonna have to do this effectively for, well, every single parameter, aren't we? So how can we make it a little bit better? Well, we don't want to do it for every single one, so we could do a private void report property string message string value student, and then this can be send s, and we can do message and value here. Use a semicolon. And then from report, we can do this report property. Oops. First name. Can't forget my double quotes there. This first name. Or we don't even need this in this instance. You can use this if you'd like, if you want to be explicit, but you don't actually need it. So we need this 6 times, right? Middle name, email, address, phone number. Change these. Email. Voila, we have a report. Or am I able to move on? Our constructor increment that static student count number with the ++. So don't forget that. And while you are all copying report, to public get total students will return student count. So I think that certainly covers all of our cases. Any questions on this? Ooh, I don't really know what.
Where did you put in your folder structure?
Under console. Okay. The other one we need to make is a student list, right? So let's look back at the README. Create a roster class. This is going to be the array of students. Give it a report method. Yep.
Can we run this code so we actually, I'm a little confused on what it's doing exactly.
Sure. I have to, we're going to have to, we'll run it. We'll run it for sure. Yeah, we have to add more to make it work. It doesn't quite work yet. It won't do anything. But we'll get there. Yeah, we'll run it before we leave. So we're going to create a roster. We're going to give it a report method that in turn calls the report method of each student in the list. Refactor your code to use these new classes and methods. Okay, so let's create a new class. We're going to call it roster.java. Page console public class roster. Ooh, roster. We're going to go ahead and import in the hash map in the array list, and I'll show you why. Array list student roster new array list. Oh, all right. So the array list on the roster, it's going to be private and it's going to be instance, right? Because every time we create a new roster, we're going to want that roster to have its own set of students. They don't want to share them. They for sure don't want to do that. So constructor, we're going to make it nice and simple. Literally nothing in it. And actually, the nice thing about Java is when you have this is the case, you don't even need a constructor. What we're also going to do, because we have a little bit of work to do with our hash maps, is we're going to create a function on this. It actually takes in the hash map string called student map. And it's going to turn this into a student object and store it on the roster. These keys are going to become very important, right? We're going to need these somewhere shared. And I think the best place to probably put it is back on that student class. And the reason why is we're going to be using these keys not only to get input from the console, but we're then going to be using them to extract information from the hash map about the student. We can go ahead and do so this is a question of how much do you want to encapsulate. And I think we're going to do the lazy thing. This isn't best practice, but we're going to do the lazy thing right here, where we have our keys here, and we're literally going to have our keys defined in here as well. So this is our keys list, and we can actually, oh, no, actually, I have a better idea. We are going to put these on the student. Go ahead and just put it there. So just copied it, put private in front of it. Public static string array get student keys. Turn student get keys. Oops. Oh, I need to make it static. Why do I need to make it static? Because they're shared amongst all the different students. There's no reason to make this, these instance-based because they're not changing at all. So those keys are on the student, and we can do get student keys. We can actually remove it from this console.io.java file. Right here where it says keys, we can do student get student keys. Oops. And it'll effectively be the same thing. For some reason, though, it's not auto-completing those things for me. But anyway, to that same point, we can go ahead and get our keys out. All right, so for add student map from map, what we basically have to do is we have this hash map from students which we get from the standard input, right? So we're building this hash map, and then we're gonna have a key first name, and it's gonna map to a first name, and then we have a key last name, and it's gonna map to the last name and all that, and then we're gonna eventually have to plug that into the student's constructor. So it's not gonna be as pretty right here in this roster because we don't have a direct relationship between the first name necessarily and the the student's constructor, right? So we don't have a direct relationship between these keys and parts of the student constructor. And there's ways that you can get really fancy with Java to do this for you, but we're going to have to be pretty manual. So these keys are manually defined here on the student. When we want to get a value out, we're going to have to manually grab it from the hash map and then inject it into the student. So we're going to have to do string first name equals student map dot get. And this is going to be first name, right? Because it's got to match that key. We're going to have to do this for all of them, unfortunately. Actually, I'll make this last name, middle name, email, address, and let's just verify that the student phone number. Right, so this is kind of a bummer because we have to do this manual work here to match the keys up. We would have to do this no matter where we did it, and there's better ways you can do it using special things in Java that we're not quite ready for yet. So we can make a, oops, I almost did JavaScript there. We can make him the student, right? First name, last name, I hit enter, and through the magic of VS Code, it just did everything for me. Now I have a new student. Student roster.add. Oops. Another thing we need is a report on this roster. Remember, all of our students have a report, and they're in an array list. So I could use that super fun for syntax to get this to work, right? Now that I thought about this more, it would have made more sense to have the hash map just be passed into the student. But whatever, this is the implementation we've done. We're going to deal with it. And you can easily move this over to the student too, and it could be the constructor instead of what we've done here without much work. But we're going to leave it here for now. So this is how we add a student to the roster, and we would call report. If we go over to our console IO now, we're able to bring in our classes that we've just created. And so you can see that there's some stuff that's still related to like the student that we could probably move. And we obviously don't need report students anymore. That next we can still keep here. This hash map create student, we can actually move that. to our student. Public. We create student map is what we'll call it. I just copied it really quickly. I gotta bring over this hash map, so I'll go back. You have to import Java util hash map to make this hash map type work. Put it up here. You can see now that I'm encapsulating this student map into the student. It probably intuitively makes more sense to have the student map be read from in the student class, right? So you can see as we're writing it, we're learning more about our problem and better ways to write the code. And that is something that you should keep in mind anytime you're writing any code. Okay. So I'm going to just make this a little bit smaller. And I got to go fast because class is almost over. So we're in here. We have students. We can actually just go ahead and roster equals new roster, right? Student.create student map will create this student map for us. We have student.get student keys. Goes ahead and it creates that. And then we can actually do, here's a good example. So we've actually run into a problem that I've built for us because I did something wrong. And that is we need to do a student report right here based off of that student map, okay? So if we look back in our roster, we have this add student from map. Let's go ahead and copy it. And let's actually make a public, we're going to make a public function here. And we're going to call it create student from map. And it's just going to simply return the student. Return type needs to be changed to student from void, or it won't work. And right here, this can just be changed to add student. Student. Now this code is a lot simpler in here. Nothing crazy going on anymore. See? We actually almost like this is just a really simple wrapper now as a roster. So what we can do, let's go ahead and change this to student map. I'll pass student map in to student equals student.create student from map. Then we can here just a student.report, right? And that'll give us that report for that individual student. Students no longer exist. It's now called roster. And we have to add student. And report students no longer exists. It's just roster.report. I know a lot just changed here, and it was pretty hard to follow along. I want to try to run this at least once before we leave. All right, so let's go into unsolved. Go into console. We'll do Java C star.java. See if we get any compilation errors. Non-static method cannot be referenced from static context. Did I not make that static? Oh, I did not. So there you go. That's what happens if you try to use something statically, but it's not actually static. So in student, I never made that static. So now everything's compiled. Please enter the student's first name, Carson. Howard J. 3 West Oak. Phone number 123 Is the student's information correct? Why? Would you like to add another student? No. And then we go ahead and it reports. Okay? Worked beautifully. Now, let's go ahead and walk through it one last time before we leave. And it's 9:30, so if you do want to leave, feel free. But if you want to go through like a 5-minute explanation, we will. All right. So we're familiar now with our loop of adding students, okay? So it goes ahead, we come on in here, we're going to create our scanner, system input, and we create our roster. And remember, our roster is just an empty array list of students. Not a whole lot going on here. We can add a student to the roster, and then we can report all of our students. So while we're adding students, we can go ahead and create a student map, which is a static function off of our student class, right? Create student map, which just returns this hash map, crazy hash map type. Right here. We can go ahead and fill it with our get next, which again takes in the scanner, prints out some information based off of our key or whatever, and we can load it into the map. And then right here, we're using get student keys to be able to loop through the keys individually, as opposed to having to do it like first name, last name, write 6 different function declarations. We have the loop do it for us. After that, we have a full student map. We can go ahead and create the student from the map, right? Which gives us an actual student instance. Create student from the map. If we look at this again over here, just takes in that hash map and extracts all the different values out of it into our individual strings, passes them into the constructor of the student, turns a new student instance, and then we return that student instance out into the world. Now the student has a report function that's based off of the instance, boom, which calls this report property 6 different times and just goes ahead and prints out information about our student, right? We do our normal confirmation. If it's a yes, we can go ahead and re-enter if it's not a yes, we can re-enter the student's info in case it was bad. Otherwise, we can add the student to our roster. If we want to add another student, continue, we do it again. Otherwise, we're gonna print everything in our roster, and we're done. For the people that are hanging around, any questions on this? Cool. Well, that's Java. I think this is the last time I'm teaching your guys' class before you're done, so thank you for putting up with me for the last 2 weeks. I'll try to come by your graduation, see everyone. Thank you. I appreciate it. Good job making it this far. You guys are almost done. Keep pushing. You're so very close, and it's worth it.